Hi team, my name is Aditya Nizap and today we'll look about machine learning implementation in the field of sourcing wherein we recommend auction types. So talking about opportunity evaluation, we have these three areas. The first area being, is there a problem? So yes, auction being a complicated process for end users, there is a problem in configuring the events. Does someone care about it? Yes, many clients have requested that the sourcing process or the auction process needs to be simplified for their end users. Uh, and can machine learning solve it? So yes, machine learning can understand the trend of the event creation and recommend it to the next set of users. So is this problem worth solving? Understanding the feasibility and business impact. It has a marginally high feasibility, I would say, close to neutral, but the business impact is very high. Hence, this is a problem worth solving. Understanding the CRISP DM business model. The first part being business understanding. Definition of problem is that the auction process is quite difficult for the end users to manage. And how do we define success for it? We define it using two constraints. One is output. This auction recommendation will provide us the type of auction, method of auction, lotting strategies, relevant suppliers, etc. And the outcome of this implementation will be savings optimization, increase in number of auctions created and conducted, decrease in the cycle time. Now, based on the discussions with experts in this field of auction, we have identified certain factors which are relevant for auction recommendations, which are nature of the event, category of the event, number of items part of the auction event, then the best bid differential in terms of previously received bids, number of suppliers which you want to invite in that auction event, urgency of the business, and availability of alternatives. Now, understanding the data, gathering data is an important part for machine learning. Now, for that, there needs to be uh, multiple document or auction events from different clients considering factors mentioned in the previous step. Documenting these events will get a relationship between categories, uh, the bit differential, and depending on that we can identify what should be the auction type or method. Data quality, we need to consider only those events which have been concluded successfully. Events which are in draft are basically garbage events which have not been concluded. So providing recommendations based on those events will give you uh, bad data or garbage data there. The cycle time of these events needs to be moderate. If it is taking very high time to conclude the event, it means that there needs to be some kind of optimization performed on those events. Significant savings is achieved. If savings is not achieved adequately, there is no use considering those documents for auction recommendation. Then data exploration. We have identified relationship between bit differential. In terms of, if the bit differential is very high, we tend to create a Dutch or a Japanese event wherein the pricing is determined by the buyer to bring all the suppliers to a single scale. Then urgency, whether it is an aggressive event or you can take time to negotiate. Nature of the events in terms of whether it is a buying or selling. With that, the type of auction, method of auction, and lotting strategy can be determined. Data preparation. Data needs to be split in three types of sets: training, validation, and testing. We can split it in different ratios, with a major ratio being allocated for training, then a part of it for validation, and eventually for testing. Feature selection is a critical area when defining a machine learning model. since you have multiple factors, but not all are relevant for that auction recommendation. Data to be model ready. So when I say that, the data should be structured to give limited solutions based on multiple inputs. We could have numerous factors, but it should point out to few resultant outputs, like what should be the auction type or what should be the auction method. Explosion of data would only mean that the buyer finds it difficult to interpret it. So it will be kind of overfitting scenario wherein we get a lot of information which is difficult to decipher. Then we come to modeling. Here we can use the decision tree for classification of features. We can probably use tailored model, as it gives as there are factors which give direct relation, but there are factors which have indirect relationship with the auction type, and the middle layers could help in triaging the auction configuration. Evaluation. The performance testing can be done on UAT environments by running training events with the live buyers and suppliers. The results from such events or the feedback from these users will then be considered for optimizing or retraining the machine learning model. Deployment. So initially the deployment has to be done on the user acceptance testing environment, wherein we can take the feedback from end users and then inculcate the feedbacks into a training model. It could be provided as an additional capability and not a mandatory step. So basically this feature should not be a mandatory process, it should be optional, so that in case the buyer wants to conduct the event, he should be able to proceed with it without getting affected by any additional changes there. So we are about to avoid change management there. Monitoring the event, as in terms of we need to see how many instances are there wherein the users avoided the recommendations and went ahead with their own set of rules for auction creation, and there should be a particular reason for it. So we should have a mechanism to capture that in the feedback, so that when we are retraining the model, we can incorporate those. Solution validation plan. Talking about the solution, we need to use embedded model to create the machine learning strategy. The above consideration is considering the fact that features relevant to auction recommendation have different weightages. For example, if the nature of an auction is to buy, it is always going to be a reverse auction. So there need not be any machine learning involved in it, as it is straightforward. However, in addition to a reverse auction, multiple factors like category or the bit differential could be essential in terms of defining whether it needs to be an English auction or a Japanese auction or any other auction in that matter. Hence, the model has to be specifically trained to be closely related to these features, and such custom validations are not available in any kind of open source or commercial libraries. So we'll have to build it from scratch. The feature of auction recommendation will be experimental model, which can be provided free of cost to some of the valued customers as a sandbox project. They can use it in their UAT environment, they can provide their feedback, which can then be used as a training or the retraining set for our machine learning model. Based on the adoption by the customers or their feedback, we can decide whether it needs to be rolled out to the further environment, or we can provide it as a standalone solution similar to other models. Machine learning system design. So talking about the platform, this needs to be a cloud platform, because multiple users or multiple clients will be using this on their own systems, and the training needs to be done considering the entire database of that client. It cannot be that a particular user is using this auction strategy or the recommendation of auction, and the system has to provide customized responses based on that. It needs to be a centralized solution. Learning has to be offline. The reason being, we'll have to filter out or exclude certain anomalies in the data. We'll have to monitor it and supervise it properly so that the recommendations are relevant for the users and it does not deviate from the end goal. Now, the prediction type has to be online because the results are required as and when the buyer asks for it. We cannot wait till the batch prediction happens. Talking about the last aspect of this project, which is potential risks. So, first is training or serving skew. The model needs to be trained on production data, however, it has to be validated with the UAT environment to avoid any kind of business impact. Now, on the UAT environment, the users might tend to test different use cases which could be irrelevant for actual life scenarios. However, we'll be using this feedback or use cases in our retraining process for the for the machine learning model later, which may result in serving skew. Talking about excessive latency, there could be multiple users who are using the cloud platform, and they'll have to wait if there are multiple concurrent users asking for a recommendation of auction strategy. So this is where we'll see a probability of latency issue occurring. The last point being data drift. The model would be utilized by clients from different countries or regions, so it need not be that a recommendation which is relevant for a user in US is being followed in the same manner in an African nation, wherein there could be a monopoly or a cartel of a particular commodity. So this is where we'll see some kind of data drift, which could possibly render the machine learning model irrelevant. However, we'll have to take into consideration such impacts and then retrain the models accordingly. So that was an overview of the auction strategy or the auction recommendation strategy which we can build using a machine learning model. Thank you.